Hello, everyone. Hello. Thank you for inviting me. Thank you for the team that organized this amazing event that we're having here in Shenzhen. I remember the last time I was in this same building, I think was like the anniversary of Dapp Learning. Do you remember that we did? What you also presented here, the anniversary? The 3 years of Dapp Learning, I think, or how many years? Last time here. 3 years of Dapp Learning we did the presentation here. So I'm very happy to be here again. As I said, I'm Leo Lara. I work at Steel, and I'm going to talk a bit about my job. Basically, very informal talk. Please interrupt me if you have any questions. It's all right. I work in the Ethereum Foundation in a team called Steel that is specifications and testing for every Ethereum layer. Before every was execution, but now we have every Ethereum layer, and I'm the first on the consensus layer. And what we do is to kind of, work on the coordinating all the clients on all the specifications and all the testing between the clients of the Ethereum protocol. So before, talk a bit about, before in the proof of work era we have before the merge. I'm going to talk a bit about the consensus protocol. Before the merge, we have like this one block that was mostly the transaction, and a small part was the proof of work. That made it work, that was very simple, was basically the same than Bitcoin. And it was very simple, but has like certain disadvantages that now we have solved with the proof of stake that we have since the merge, I think almost 4 or 5 years already of proof of stake. And now in the proof of stake, we have this block have like a block inside it that is the execution layer block with the transactions, and then this contained by other block that is the consensus layer proof of stake transaction. And this is the execution layer have the transactions, what people normally kind of think about the Ethereum and interface with Ethereum, and the consensus layer have all this utility to build the blockchain using proof of stake. Like it's about validators, attestation for choice. Here the actors that build the chain and decide about the chains are called validators. There are nodes that have a stake, that have put like a treasury, like a bond to contribute to the network. So they have like a financial interest to make it work correctly and have like financial incentives to do that. But those financial incentives are not like in the proof of stake. The financial incentives were based on energy cost and hardware costs. Now these incentives are based on actually holding Ethereum. So it's kind of create better incentives, we believe, And these validators kind of mainly have 2 roles to play. They play both roles. Sometimes they are testers, and sometimes they are proposers. And when these roles are chosen for the validator is based on a pseudo-random algorithm called the RANDAO that is based on all the previous blocks. So you cannot really tamper with it, because you need to kind of like be able to produce a lot of blocks in succession that will be financially impossible and very unlikely. For some reason, sorry. So this is cool, proof of stake, everyone. If you have any question, let me know. So to run an Ethereum node, basically you need to run 2 software, an Ethereum execution client and a consensus client. And there is something in Ethereum that also another advantage with respect with Bitcoin and other protocols. We don't have just one implementation of this client. We have what we call client diversity. So the execution client, there are 5 main implementations, all in different programming languages, all done by different teams. And the consensus client, the consensus client has 6 implementations, all done by different teams. Some languages are being repeated, like I think Grandin and Lighthouse use the same, but programming languages, so I think 5 programming languages by 6 different teams, they kind of implement the same protocol. And that's why where my team still kind of comes, they have a very cool logo and a very cool name, kind of comes into play to organize this, to kind of have like a implementation of the core of the protocol in Python that is not really efficient enough to be used, but is kind of the reference that all of them use to implement them, and then create from there a series of tests that all of them can use to test with the same test all these 7 all these 11 softwares based on the same test vectors. Cool? Yeah. So one of the most important things that the consensus layer does is the fork choice. Is when there is like a split in the network, like in the split in the chain, like the suddenly appear 2 chains, decide in the end, like make that all of them agree which is the main chain. No? So for example, like how this could happen, I have here the chain is divided in slots that they are currently 12 seconds each. So the time is divided in slots of 12 seconds, you know, and because of the rundown that explained, decide which of the validator is the block proposer for each of the slots. No? So validator 1 is the block proposer for this slot, and then creates like a block, and then validator 2 is the block proposer and creates another block. But then, I don't know, like World War III starts or something, and the internet, like different continents cannot really connect, or the latency becomes very huge. So validator 3 creates a block, but when validator 4 is the proposer for this slot, is going to create a block. It hasn't seen this because the network is split, for example, and then it will create a block with this parent because it hasn't seen this soon enough, no? Because it has an allotted time to create the block. And then from there, perhaps like 2 different chains start to be, wouldn't be here because this slot cannot be created by the validator, but then 2 different chains start to propagate, to be created, yeah. Yes, so there's like a fork. And the most important thing, the more important role of the consensus layer is the fork choice. So it's kind of choose which one of them we have to choose, like kind of like make in the end all the nodes agree on which of them should be chosen. Yes. I'm sorry. So there is 2 algorithms that the consensus layer in proof of stake uses. There is the Casper FFG and the LMD Ghost. At the same time, they are connected. The Casper LFG is kind of more high level, so it decides there is like what we call finalized checkpoint and justified checkpoint. So when we get to a node gets to a finalized checkpoint, that is really definitive. It cannot be changed ever. So all the 4 choice options from before can be completely ignored always. And this is kind of complete finality for Ethereum, the finalized checkpoint. And then there is another justified checkpoint that is after the finalized checkpoint always. And For the time being, as long as this is difficult to change, but as long this doesn't change, the nodes are going to ignore the rest of the possible forks, okay? And then from the justified checkpoint onwards, the nodes are applied the LMD ghosts. So then kind of going more like low-level detail. And this make it efficient, no? Because like the LMD ghost goes to count the attestations in each block, etc. So by the fact of only doing it from the justified checkpoint onwards, we couldn't do it for the whole blockchain, no? So we just do it for the justified checkpoint always. So, and then basically from the attestations, the LMD goes kind of give a weight. So see count the attestations that are like the other validators that are not the proposers, create attestations from different blocks and assign them. And basically the LMD ghost, the LMD ghost kind of give a weight to each block depending on the attestation and also depending on the balance in Ethereum that each of the attestations come from. So each attestation comes from a validator and the validator have a balance. So if you have more balance, you have more weight in your attestation. There is basically a vote for which is the chain to choose, no? And then based on this LMD goal algorithm of taking into account the attestations and the balance of the attesters, is chosen, and eventually all of them converge on this decision because they all start seeing the messages from the rest. Yeah, that's kind of like what the most important thing that the consensus layer does, no? The consensus layer also kind of keep the accounting of who are the validators, how much balance they have, etc. But all this is done with the intention of being able to do this other thing, that is kind of doing the fork choice based on the validator attestations and their balances. Yeah, is that okay? Yeah. So basically, what it still does, to go more about this, no, there are a lot of AIPs, no, the Ethereum improvement proposals, and that really create each version of the protocol. We need to think like Ethereum do huge upgrades like every year, and probably in the future twice per year, like a very complex upgrade to the protocol and the new features. Like lately we had blobs that help like make L2s cheaper. All these very big changes. They are codified in AIP, and what my team does kind of like codifies all these into what we call a specification in Python. That all these clients software are going to use to implement in their own language that is not Python, in Rust, in Go, etc. But they are going to base on the same source that is Python. So that's kind of helps guarantee that in the end they are going to do all the same protocol. No, this is the main difficulty, have like these 6 implementation exactly doing things exactly the same. And also then we build these tests. This kind of like, it's not unit tests exactly, but kind of like unit tests in Python as well for this spec. So we see that the spec passed this test. But then from this test itself, we extract the data, the actual values that are being tested, and we create like test vectors, files, etc., that all of these clients consume. So they have like this kind of bank of tests that all of them consume, and all of them run on their own clients, and that way they make sure that they are all following the spec, and they are all passing the same test, and it's kind of converging completely, no? And they all like we run dev nets that are kind of like small blockchains that are running on all the different clients at the same time. Many times, many devnets are run before a new version of the protocol is created and is launched, and make sure that all this work, and we see the problems here. And the problems that come here can revert into more tests here, and the client teams also contribute to the tests, and then this goes like to all the clients again to run the test or even kind of improve the IPs and the specifications. And we see like there is like a bug in the specification and the specification needs to be changed. Yes. So here I have an example. So for example, this is the process attestation in the spec. So this is in Python, no? And it's actually the code of how the client should process the attestation. So we write in Python. And then all the clients are kind of in their own, more optimized, because this is more implemented for readability, etc. in Python, and it's not efficient, but more like looking more into efficiency. They implement, we expect that they implement the same algorithm, okay? And then we have tests, like for example, this one, that test this method. Test this method like you do like in any normal unit testing. You have a method, you put different inputs, different outputs, and you check that you are agreeing with the output that should has, no? And then more on that, in this case, like this will create like 3 files. This test will just test it tests this function in Python, but also create these files with the pre-state of the chain serialized before calling the method, and the state of the chain after calling the method are actually the attestation that is the input to the method. So that way, thousands of these are shared with the client teams, and all of them are going to test their own process attestation function with this same data. Yeah, and that's kind of the story of what we do. And if you have any questions, let me know.
Are the tests not formally verified? So it's more like you guys find something that breaks and then you write the test?
No, but we usually, for any new feature and any EIP, when we try that it comes with tests. So it's not, we don't expect like the devnets to fail to write the tests. So we try like all of them have enough tests and try to preemptively write tests that kind of test corner cases, etc. But yes, of course, like there are bugs, and then they fix it, but they also want to add the test so it doesn't happen in the other clients. No.
Do you include any form of formal verification?
No, I think there is some people working on formal verification of the Ethereum protocol, but not in my team.
Okay.
Yeah.
还有什么其他问题？
How do you make sure there are enough nodes for the DevNet?
That's another thing. There is a team that is called If Panda Ops that run the devnets. There is like a DevOps team. But yes, like they have like many nodes of all the clients, but I don't know the amount they have. I don't know how many they run. But the devnets usually are internal, so it's not like Sepoli and all that anyone can participate, but the devnets are usually like the client teams run them, like their clients, I think with If Panda Ops, that is another team in EF, together they run a cluster of clients. Yeah.
I see. Okay, I have one more question. I know the dev write the spec Python scripts, then you write the test of, yeah.
Yes.
So how can the different clients team to consume your test script?
How they consume? They create their own consumption. So the test in the end. So going.
Which language
Yeah.
do you use?
Python.
The same.
No, but all the clients use different languages.
Yeah.
So let's go to your question. Like we write the test like the. So what we try, like first like the AIP writer, we try that them like send the version of the AIP as a Python spec with Python tests already. So they send it like submitted to the repository in that way with the Python spec and the Python test. And then the second question kind of like, so we generate files in like serialized objects like state, attestations, blocks, like in a folder, each test like in a folder, and usually there is a meta YAML file with more information, and each of these folders is one test. And each of the client team have to implement in their client a consumer for this format. So if the client teams have a consumer for this format. Yeah, consumer. Yes, for this one. Yeah.
Different team need to write to different consumer.
Yeah, so each team has its own consumer for the same format, yeah, for the common format that is produced from the Python tests.
Hello. So my question is that the Beacon API stack is covered in a separate repo, right? Is it also maintained by Steel team or?
Yes, so we are with the, I mean, it's something very collective, no? Like it's in the Ethereum organization and it's kind of, there is one repo, so the execution is in two repos. There is one for the test and one for the specs. In the consensus, we have one repo that is called Ethereum/consensus spec, and that will have the specs and the tests, and it's really like there is the EF security team, Steel, like me from Steel, because I'm the only one in the consensus in Steel because Steel was born in execution, and then also people from other client teams, also kind of maintainers and contributors. So it's like, it's not, it's decentralized as much as it can. I mean, like there is like, I think 6 maintainers from different organizations. It's not, yeah, it's not, we try, at Ethereum we try that everything is very decentralized and kind of like, not, yeah.
So my question about the Beacon API spec is, it only provides the open API schema, but it doesn't provide any test or test data, like
yeah.
integration.
I think you talk about the RPC.
The RPC.
The RPC.
API endpoints.
Yes, but that's where we handle the communication between the nodes. But that's kind of like the main part that actually the rich consensus the nodes between themselves. No, more than like a client software communicating with the node. You know what I mean? Yeah.
Yeah.
I don't know the test for
the how to reach consensus attestation is.
Yes,
like
yes.
More like internal functions.
Yeah, but that doesn't go. Yeah, that doesn't go through the RPC. That's go with peer-to-peer messages and all that. Yeah, but we actually are not. Well, other teams test the network, but we kind of like test kind of the core of the logic without the networking. You know, like yeah.
Yeah. What I'm trying to do, I'm trying to test the Beacon API endpoint for a new client called Ring.
Yes.
The problem is that there's no universal Beacon API integration test. Like, is there any plan to create such test?
I don't know. Yeah, I don't know. Yeah, because each client, I guess, they have the RPC. I think for the execution layer, there is a common RPC, no, that the clients use, but for the consensus layer, perhaps there is not.
Yeah, but I couldn't find one for consensus.
Yeah, perhaps there is not for consensus.
Some of the team like Nimbus, they create some like API test suits for the Beacon API.
Yeah, it's like I think it is like from the point of view of the wallets. No, if you're building a wallet, you only need to talk with the execution layer. So I guess they haven't thought about which type of applications want to talk to the beacon node. So, I mean, what you can do is to run your own node and choose Nimbus, for example, and use that one. Yeah, and use only the Nimbus one. Yeah.
You mean maybe adapt the test, API test from another client?
Yeah, like choose one client and use that, no? Because because the clients are all communicating through the P2P, so you run your own client of the consensus layer, you communicate with that one, and that's kind of like should give you the vision of the network. Yeah.
Cool, thank you.
I guess it depends on the application, yeah. But
好，这边看到一堆是手机要问问题，
一样的。
还有什么其他问题啊？你们最后一道的问题啊？有没有想问的？没有的话，这样我们就早上就这里结束。我们先谢谢一下Leo。然后我们下午之后还有多几个 talk， 本来是说2点的这里，但是我们先改去2点15分吧。所以大家想听下午的 talk 的话，请2点15分到1样的 talk。谢谢大家。